Sometimes I look at numbers and feel like some just click. They have this hidden order. Like, imagine a number that has to be perfectly divisible by the sum of its own digits.
It sounds almost, well, neat, doesn't it? And that's exactly what we're digging into today, Harshad numbers.
Harshad numbers, or Niven numbers, I think they're also called.
That's right, Niven numbers is another name. But I really like the original term from Dr. Kepperkar. It comes from Sanskrit. Hara, meaning joy, and da, meaning give.
Joygiver. That's lovely for a math concept. So our mission today is basically understanding these joy givers.
Exactly. Let's unpack what they are.
Okay, so the basic idea, let's stick with base 10 for now. What makes a number a Harshad number?
Okay, simply put, a positive whole number is Harshad if you can divide it evenly, no remainder, by the sum of its digits.
Gotcha. Give me a quick example.
Sure. Take 18, its digits are 1 and 8. Add them. 1 plus 8 is 9.
Right.
And 18 is perfectly divisible by 9. So, boom, 18 is a Harshad number.
Simple enough. And, I read that the famous Hardy-Ramanujan number 1729. That's 1, 2.
It absolutely is. That's a great example. Add up the digits. 1 plus 7 plus 2 plus 9. That gives you 19.
Okay, 19.
And 1729 divided by 19 is exactly 91, no remainder. So 1729, the taxicab number, is also a joy giver.
That's pretty cool.
Yeah.
But wait, there's a potential trap here, isn't there? In base 10, we have that rule for divisibility by 9.
Ah, yes. Good point.
Does that mean any number divisible by 9 is automatically Harshad? Because, the digit sum rule?
That's the crucial mistake people might make. No, not always. Take 99.
Okay, 99. Divisible by 9, obviously.
Right, but what's the sum of its digits? 9 plus 9 is 18.
18, nah.
And is 99 divisible by 18? No, it's not.
Right, it leaves a remainder, so 99 is not Harshad. Got it.
Yeah.
You only sum the digits once.
Exactly. Now, here's where it gets, well, more complex. This whole property, it really depends on the base you're using.
Base dependency. Okay, so a number might be Harshad in base 10, but maybe not in, say, base 8.
Precisely. Take the number 12. In base 10, sum is 1 plus 2 equals 3. 12 is divisible by 3. It works. Checking at other bases, it usually works. But try it in octal, base 8. 12 in base 10 is 14 in base 8.
Okay, 14 in octal.
The digits are 1 and 4. Sum is 1 plus 4 equals 5. But is 12 divisible by 5? Nope.
Wow, so 12 is Harshad in most bases, but not octal. That really highlights the base thing.
It does, and it leads to a really interesting question. Are there any numbers that are Harshad in every possible base?
The universal ones. All Harshad numbers, right? Are there many?
Very, very few. In fact, we only know of 4. Just 1, 2, 4, and 6.
Only 4. That's it?
That's it. Although there's a simpler property, too. Any single-digit number, like 7, is always Harshad in its own base because it's just divisible by itself.
Okay, that makes sense. One digit, sum is the digit itself. Divisible. Simple.
Right. The complexity comes with multiple digits and different bases.
It really shows how structure and rules can create these fascinating, intricate systems. Thinking about that kind of complexity and needing things to work together smoothly.
Yeah, it often requires sophisticated tools, especially in the digital world. Like if you're dealing with AI training or automation or software development projects, getting that internal order right is key.
Absolutely. Which actually brings us to our sponsor, Embersilk. If you're facing those kinds of complex digital challenges, needing help figuring out where AI agents could really make a difference for your business, or even just for your personal projects,
they're the ones to check out. Embersilk helps uncover those high-impact areas and manage the integrations.
Definitely. So if you've got complex AI needs, have a look at embersilk.com.
Good point. Now, going back to these numbers, if you think Harshad numbers are interesting, wait until you hear about Niven morphic numbers.
Niven morphic. Okay, that sounds intense. Break it down for us.
Let's try.
Bye.
So you start with a number, let's call it T. Say 18 again.
Okay, T is 18.
Now, 18 is called Niven morphic. If you can find some much bigger Harshad number, let's call it N.
A bigger Harshad number, N. Got it.
And N has to meet 2 conditions. First, the sum of N's digits must be exactly T, our original number 18.
So digits of N sum to 18.
Okay. Second, the number N has to literally end in the digits of T, so it has to end in 18.
Whoa. Okay, wait. So for 18, does such an N exist?
It does. The number 16,218, check it. Is it Harshad? Sum of digits. 1 plus 6 plus 2 plus 1 plus 8 equals 18. And 1/16 through 18 divided by 18 is 901.
Yeah.
Yes, it's Harshad.
Okay, condition 1 met.
Does it end in 18? Yes, it does.
Condition 2 met. So 18 is Niven morphic. That's surprisingly specific.
It is. And here's the kicker. Almost every positive integer in base 10 is Niven morphic. There's only one known exception.
Only one number fails this. Which one?
11. The number 11 is the only one that just doesn't seem to work this way in base 10.
Huh. 11, the odd one out again.
Yeah.
That's wild. Okay, so we have these specific properties, these exceptions. What about patterns? Like,
Yep.
can you get strings of Harshad numbers in a row? Consecutive
Good
ones?
question. Yes, you can find consecutive runs, but there's a limit.
A limit.
Yeah. In base 10, it's been proven. You cannot have 21 consecutive integers that are all Harshad numbers. It's impossible.
Never 21 in a row.
Yeah.
Okay.
But people have found infinitely many examples of runs of 20 consecutive Harshad numbers.
So 20 is possible, lots of times even, but 21 is a hard no. That's fascinating, these sharp boundaries in mathematics.
It really is. It hints at deeper structures.
So beyond just being, a fun mathematical curiosity, do these Harshad numbers tell us something more fundamental about integers?
I think they do. Consider this additive basis idea. Research suggests that basically every natural number, well, at least up to a billion where they've checked,
Yeah.
is either a Harshad number itself, or you can make it by just adding two Harshad numbers together.
Wait, really? So any number under a billion is either Harshad or the sum of two Harshad numbers?
That seems to be the case.
That's huge. It's like they're fundamental building blocks then, not just a quirky subset.
Exactly. They might be part of the essential toolkit for constructing other numbers. It points to that hidden order we started with.
Wow. These joy givers are more important than they look. What a great place to pause and reflect.
Indeed. There's always more to uncover.
Well, if you enjoyed this deep dive into the surprising world of Harshad numbers, please subscribe to the show.
Yeah, let us know what you think.
And hey, leave us a 5-star review if you can. It really does help get the word out about these kinds of topics.
It really does.
Thanks for tuning in.